Hey, welcome to Trig equations. We are starting with the very basic of trig equations in our current unit. If you notice, let's look at the question here. Also, this says intro to trig equations and understanding the requirements of the question. Once I get to this, I'll let you know. But let's understand what this question is asking me. This one's saying, is pi over 4 a solution to this equation? And then they're also wanting me to test if pi over 6 is a solution to the same equation. This equation, the way we read it, this is twice of sine theta, so 2 times sine theta minus 1 equals 0. Clearly it's an equation because it has an equal to sign. All I have to do is plug in pi over 4. Now the unknown in this equation is theta. Usually in our other equations, if I had 2x minus 1 equals 0, in algebra, we know the unknown is x, and we work out the equation to be able to find the value of x. In this case, the unknown is theta. The angle is what we have to find. So let's go ahead and plug it in. 2 times sine of pi over 4 minus 1. Does that equal 0? That's the question. Let's keep solving it. Sine of pi over 4. What's the value of sine pi over 4? Pi over 4 is basically 45 degrees. 45 to 45, 45, 90 triangle, 1, 1, root 2. Sine is opposite over hypotenuse, so 1 over root 2. And then minus 1, does that equal 0? That's still the question. I'm going to go ahead and combine this. 2 over root 2 minus 1. Does that equal 0? To be able to make them equal to each other, I'm going to multiply both of these by root 2. That makes it 2 minus root 2 over root 2 equals 0. Does that equal 0? This is clearly not going to equal 0. Because this is not equivalent to 0. Whatever it is, it's not equivalent to 0. So the answer here will be no. It's not a solution. We were testing for pi over 4 here. Let's go ahead and try out pi over 6 now. We'll do the same thing. 2 times sine of pi over 6 minus 1. Does that equal 0? Let's try it. Sine of pi over 6. Pi over 6 is basically 30-degree angle. Pi over 6 is a 30-degree angle, so 30, 60, 90. The one opposite to 30 would be 1, 2, and root 3. So pi over 6 would be half. That's half. Minus 1, does that equal 0? That would be 1 minus 1, and that does equal 0. So yes, pi over 6 is a solution to this equation. So the first one was not, and the second one is. This is testing it. All right, let me now go ahead and think about this for the same question. What other solutions would qualify? Like we tested out that one is and one isn't, but are there any more possible solutions to this equation? Let me write the equation again. I'm going to go ahead and solve this equation. I'm going to add 1 to both sides. I'm going to divide both sides by 2. And now we're looking at all possible thetas. All possible theta values where sine is half. Now, sine is half. Like sine is going to be positive in the first and the second quadrant, right? Because sine is the pi value, which means there is a possible theta here where sine is half, opposite over hypotenuse. And then there is another possible theta here, 1 and 2, where sine is half. So both these theta that satisfy the equation right now will be the answers. It's not possible in the third and the fourth quadrant, so I have crossed those out because sine will be negative in those two. Which also means this would be root 3 and this side would be negative root 3, although there's no role of root 3, but I still went ahead and put it there just so you recollect that, hey, these are 30, 60, 90 triangles. Now, which one's 30, which one's 90, which one's, obviously this one's 90. Which one's 30, which one's 60 depends on the smaller side. The angle that's opposite to 1 would be the 30-degree angle. So this angle is a 30-degree angle. Hence, I found one solution to theta, which is 30 degrees. If this is 30-degree angle, what angle would that be? That would also be a 30-degree angle. However, this is the reference angle. This is the reference angle. The actual angle made by that ray is this angle from 0 all the way here, which would basically be 180 minus 30, which will make it 150 degrees. So if you notice, those are the two solutions in one revolution. Let's think of all solutions. Did they restrict me to one revolution? They actually did not restrict me to one revolution. But what we did figure out so far, that in one revolution, there are two possible theta values where sine is equal to half. Let me go ahead and convert this to radians. That would be pi over 6. And this would be 5 pi over 6. Again, are these two the only solutions? No. Now the next solution here would occur after another full rotation. That will be the next angle. And one full rotation is 2 pi. So if I take pi over 6 and add 2 pi to it, I would get the next angle there. Now 2 pi, to be able to add it to pi over 6, gotta times it by 6, which will make this 6 and 12, which makes this 13 pi over 6. But is that the only one? Again, that was two rotations. If you take another rotation around, then we would end up with the next solution, which basically means if I now add another 2 pi to it, 25 pi over 6, that would be the next solution set. Now, is there any end to that? There is no end to that. So pi over 6, next solution at that location would be 13 pi over 6, followed by 25 pi over 6. So I went ahead and calculated 3 of them. Honestly, if you notice, you'll figure out a pattern here. Pi over 6, 13 pi over 6, 25 pi over 6. The next one would be, we're basically adding 12 pi in the numerator. It would be 37 pi over 6, and so on and so forth, right? So that's from that location. If I go to the 5 pi over 6 location, where the second answer came from, again, if you keep rotating over and over again, we're going to get the next set of answers, which means 5 pi over 6, and the next one will be, remember we were adding 12, so I don't even have to do the math anymore. Next one will be 17 pi over 6, plus another 12 pi over 6 will make it 29 pi over 6, and so on and so forth. Another 12 will make it 41 pi over 6, and so on and so forth. So how will I write my answer? All the possible thetas, we're looking at all solutions. I'm looking at pi over 6, 5 pi over 6. I'm going to go in order. Then comes in 13 pi over 6, 17 pi over 6, and so on and so forth. There are infinite number of solutions. It's important to notice here that I said all solutions, which means there was no restriction to the set of answers. Another way to write this is pi over 6 was the first answer. The idea is that we're adding 2 pi over and over again. Per rotation, we're adding 2 pi. So instead of just writing 2 pi, if I write down 2 pi k, where k represents an integer. K is an integer. What are integers again? The positive numbers, no decimals, no fractions, the positive and negative numbers. If I write it this way, then I have taken care of this entire set that I kept going on and on and on and on. Instead of repeating that over and over again, I could simply write it in a much better format where k represents an integer. So if k is 0, I'll get the very first answer, which is pi over 6. When I plug in 1 for k, I'll get the next answer, which is 13 pi over 6, and so on and so forth. That is from the first one. And then the second possible value of theta would be, the second answer was 5 pi over 6 plus 2 pi times k, where again k is an integer. So this is another smart way to write the answer, just because there are infinite number of answers. I hope that made sense. Here's another way to write all solutions. Dot, dot, dot represents there's no end to it, infinite solution. Hope that was helpful. See you in the next one.